Yeah, guys. Now you understood the Kubernetes architecture diagram, right? Is the Kubernetes architecture. Yeah, Kubernetes diagram, Kubernetes architecture. So now you understood, right? In the control plane. So what are the attributes are there? API server, scheduler, control manager, etcd. So what is API server? What is scheduler? What is control manager? What is etcd? So guys, tell me what is etcd? So API server, I already told you, right, guys? Yeah. So this is the Kubernetes diagram. So what this is a control plane, and these are the worker nodes. So we are deploying our applications in the worker node. We are deploying our application in the worker node. So we will deploy this architecture will be a self-managed architecture, self-managed Kubernetes architecture, or a provider managed architecture. Provider manager, so Kubernetes architecture. So self-managed architecture, self-managed Kubernetes architecture. So how many instances? A node is nothing but a instance. What is that, guys? A node is nothing but a instance. So how many nodes we need? Guys, how many nodes we need?
3 nodes. One
Yeah,
is
we need.
master, three.
So how many nodes we need? So we need a three nodes. So first, so we want to connect. So we want how we can connect the control plane, guys. So we will connect the control plane to. So we will connect the control plane, right? So this is the control plane. So how you can connect through the control plane? You can connect through the control plane either open lens or CLI or GUI. What is GUI? What is UI or GUI? Right? UI, user interface. So user interface is the open lens. What is that, guys? Open lens. So open lens is the user interface, and kubectl is the, what is that? Kubectl command. This is the CLI command. Okay, CLI command. If you want to connect this control plane, so if you want to connect this control plane, so if you want to if you want to connect this control plane, so you can connect this control plane through kubectl or kubectl command or openlens. Openlens is the third party tool. What is that, guys? So third party tool to connect the Kubernetes cluster and kubectl. What this is also a node. This is also a node. Node is nothing but a EC2 instance. What is this? So this is a EC2 instance. So we can connect this. So why we are not applying any commands? These kubectl commands on master node. This is the master node, right? So that's the reason. If something goes wrong, it will the entire Kubernetes architecture will go wrong. That's the reason. So we will not apply these kubectl commands on the master node. So we will create another EC2 instance remote node, and so this kube config file. What is that, guys? So this kube config file, we can copy this kube config file into cube config file into or remote server. So how you can connect this? So how you can connect this master node? You can use the kube config file. So once we install the Kubernetes, right? It created the kube config file. So if you want to connect this in the OpenLens or a CLI, definitely we need a kube config file, guys. What we need? We need a OpenLens. This is the, yeah. For example, so this is the OpenLens. We can connect the For example, this is the open lens, guys. So what is that? Dot cube config file. So this is the a cube config file. So we can copy the cube config file for cube config file on the open lens and remote CLI. So if you want to connect this Kubernetes cluster either open CLI or you can connect with the remote mission. Okay. Yes. So this is the master node and these all are the worker nodes. For example, in our case, you created the how many master nodes, guys? You create the one master node and two worker nodes. What is that?
One master, two worker.
Yeah. So one master node and two worker nodes, right? So here, so we have a API server. What is that? API server. So etcd, controller, scheduler. So these are the key components in the master node. Here, kubelet, kube proxy, and container, Docker container, and your containers. The default kubelet, kube proxy, and Docker containers. These all are the your containers, right? If container, so for example, so who will tell? So you are trying to create you are trying to create a pod. We're trying to create a pod on this. So a pod is nothing but a logical unit of container is nothing but a pod. So in the Kubernetes architecture, so we are calling it as a pod. In that pod, we will create the containers. Most of the time, a pod contains a most of the times a pod contains a one container. A pod contains a one container. Guys, understood? So this is the Kubernetes architecture, guys. What this is? Now you understood, right, guys? Guys, understood the Kubernetes architecture?
Yes.
Very good. So it is very easy, guys. The Kubernetes architecture is very easy. If you learn the Kubernetes architecture, it will be very easy to understand the Kubernetes concept, right? So this is the kubectl. Kubectl will call to the API server. API server will call to the will store the information in the etcd. So right here you see. So execute a command by kubectl that will talk to the API server, and API server will act as a mediator between kubectl and the Kubernetes software. So this Kubernetes software and kubectl, so this will API server will act as a mediator. So whenever a request from the kubectl that will be taken care by the API server will talk to the underlying Kubernetes software. So who will take care, guys? Who is the main module in the Kubernetes cluster? So what is the main module in the Kubernetes cluster, guys? API server.
Yes.
So whenever a request from the kubectl or a open lens, so the API server will take it and will move forward. So the API server execute a command by the kubectl apply. So for example, so what is that, guys? So we need to create a yeah. So for example, so this is your YAML file, guys. What this is? This is your YAML file. For example, so you want to create a pod. You want to create a pod in the worker node. So you want to create a pod in the worker node. So what is the command, guys? This is the what is the file, guys? Webapp.pod.yaml. What is the YAML file, guys? So your manifest file. What we call it as? This call it as a manifest file. So what is the manifest file? A manifest file contains the information about the pod and the metadata, labels, so specs. I will tell you, no worries, guys. Right? For example, this is our manifest file. So if you want to create a pod through the a file, if you want to create a pod through the file, so we can execute the command looks like kubectl apply -f forcefully. So we need to create create a pod using the manifest file. So what is the manifest file? Kubectl apply -f java web app pod.yaml. So what is that? So what is this? So this is your AML file. What this is, guys? This is your AML file. So you created the AML file in the, so you created AML file here. So you are trying to apply the command. So which command? kubectl, kubectl apply -f manifest file. What is your manifest file? Java web app pod.aml. So this is your AML file. So right. So this is your AML file. So if you click this kubectl apply -f web app pod.aml. So this web.aml file contains the data, right? So this API server first take the API server and will store the data, whatever the data is, right? We'll store the data in the HCD first. What is HCD? HCD is the a database file where we can store our data, right? So that this data will be stored to the HCD. Yeah. So execute a command by the kubectl that will talk to the API server, and API server will act as a mediator between kubectl and the Kubernetes software. So whenever a request comes from the kubectl, that will be taken care by the API server. So whenever a request comes from the kubectl or OpenLens, that will taken care by the API server will talk to the underlying Kubernetes software. Okay. So whenever a request comes from the API server, so an API server store the information in the HCD server. The API server first store the information in the HCD server. HCD, it is a data store. It is a database, something like data store in the Kubernetes. It will act as a database to store the details of the Kubernetes cluster. So it will store the details of the Kubernetes cluster. Then scheduler is going to check what are the pending tasks are available. Then scheduler is going to assign a task to the controller. So here, right? So there is a file and pending to create a pod. So who will take care of this? The scheduler. So whenever a request comes from the API server stores the information in the HCD. HCD is the data store in Kubernetes. It will act as a database to store the details of the Kubernetes cluster. Scheduler. So once the scheduler is going to check the what are the pending tasks are available, then scheduler is going to assign the task to the controller manager. So that is a scheduler will check it. So what are the pending tasks? There is a pending task to create the pod, right? It will assign to the control manager. So it will assign to the control manager. Control manager is going to schedule them before going to schedule. So it will be schedule them before going to scheduler. Scheduler will talk to the kubelet. So right, it will controller will schedule it and scheduler will talk to the kubelet. So what is a kubelet? Kubelet is the agent of the Kubernetes worker node. So in the worker node, kubelet is a agent. So agent will validate. So agent will validate if the pods are running healthy or not, if the container is healthy running or not, if the Docker service is running or not, if the network is the network is assigned or not. So who will check, guys? That kubelet will check. And so every time the kubelet will talk to the control plane. So control plane. So there is a request comes from the control plane. So what is that? We need to create a pod. So who will create the pod? The kubelet will create the pod and pod. So first kubelet verify the in which worker node there is a space or there is a resources. So for example, in the worker node 1, the resources are full and there is no resources to create the pod or a container. Then it will come to the worker node 2 and it will create the pod. And so we have a 4 worker nodes. So the pod worker node 1, worker node 2, and worker node 3, and worker node 4. So up to worker node 3, all are completed. The only the available. So if you want to create it on the worker node 4, then the kubelet will talk to the worker node 4 and will create the pod. Will create the pod. Guys, understood? So kubelet is a worker node agent. It is going to check health of the node. First, it will going to check the health of the node. Kubelet will check the resources available in the node. For example, the resources are not available in the node 1 and node 2. So the resources available in the node in kubelet will make sure pods are running successfully and containers are running successfully. So for example, the space is available under the worker node 2 and kubelet will create a container with the help of a Docker container and So it will run smoothly, successfully. It will create the container and pod running successfully. Kubelet will create the containers on the worker node using the pods with the help of Docker runtime. So with the help of Docker runtime, who will create the guys? Kubelet. So we are using to create a container. So who will create the Docker container? Docker runtime, guys. Container is nothing but runtime of our application. What is that, guys? So container is nothing but a runtime of our application. Guys, now you understood Kubernetes diagram?
Yes.
Hmm. Now, how to install the Kubernetes? How to install the Kubernetes? So Kubernetes is a orchestration, container orchestration management tool. What is that, guys? A container orchestration management tool. So it will manage the containers. So who will manage the containers, guys? Kubernetes. Kubernetes will manage the container orchestration, container architecture. So how we can install the Kubernetes? How we can install the Kubernetes? So we can install the Kubernetes by two ways. So one is self-managed Kubernetes cluster. The other one is provider manager Kubernetes cluster. Right, guys? So same like as so in data center, VM virtual machine, we need to create a manually each and everything, right? So if you are launching a instance in the EC cloud, so it will be very easy. It's a predefined environment, right? It's already defined. Just one click, it will automatically create the environment. The same like as a self-managed and provider managed. Self-managed, so we need to create each and everything in our own. So we need to take the three servers. So one is for control plane, the other two is for worker nodes, the other two is for worker nodes. So if you want to run the Kubernetes cluster, right, so we need a big resource amount of the instances. So for example, T3 medium. So T3 medium, minimum 4 GB of a RAM. So if you want to install a Kubernetes cluster, we need at least 4 GB of a RAM. So that's the reason. If you took the T2 micro, T2 medium, T2 micro and T1 micro. So if you use those, right, they will get the 1 GB 2 GB RAM. So we need a 4 GB of a RAM to install the Kubernetes cluster, right, then we will go with the T3 medium. We will go with the T3 medium, right? So you can create your self-managed Kubernetes cluster and provider managed Kubernetes cluster. Right. So something like what is what is Minikube and what is kubeadium? What is a Minikube and what is kubeadium? For example, your master node. So your master node and worker. So your master and worker are so within the same instance, within the same EC2 instance. So within the same in one EC2 instance, so we created the master node and worker node. So we will create the worker node and master node, and so within one server, this is nothing but a mini cube. So what is this, guys? So we will install all the softwares, worker node softwares and master node softwares in one server. So this is nothing but a mini cube. What is that, guys? Mini cube. Guys, understood? So minikube. This minikube will be uh, deployed, or built in dev environments, QA environments. They will deploy it in the QA environments. It is not support for the enterprise environment, right? So kubeadium. What is that, guys? Kubeadium architecture. What this is? This is a kubeadium architecture. What is that? So we will install the master and worker nodes in the single instance, and we can install this is the cluster, Kubernetes kubeadium. So kubeadium, so we can install the Kubernetes master node and Kubernetes worker nodes in the different instances. So that is nothing but a kubeadium. So what is that? Provider managed. So provider managed. So when the cloud started, right? When the cloud started, there is no there is no containerization, there is no container concept, right? So later they released as a service as held as a container service. What is that? ECR or ECS. So what is ECS? Elastic Container Services. So what Amazon launched the service? The Amazon launched the service called as a ECS, Elastic Container Service. So if you took the Elastic Container Service, so what we will get? So we will get a AC2 instance and it installed the Docker service. It installed the Docker service on that server. If you took the if you took the Docker service, container service, so we will get the one EC2 instance. So in that instance, automatically launched the Docker container. So right, who will manage this ECR? So that installation, that management, everything will be taken care by the cloud providers. No need to worry about it. If the containers are running or not, we will check it. If the service and instances will be managed by the managed by the cloud. The same like as a provider managed Kubernetes cluster. What is that, guys? Provider managed Kubernetes cluster. So same like as a the cloud providers, they created their own provider managed services. So what is that, guys? Amazon created as a EKS, elastic Kubernetes service. So if you run the few commands, it automatically create the Kubernetes cluster. And who will manage if something goes wrong on the EKS cluster? Who will manage this EKS cluster, guys? That provider managed. Who provided? So this AWS, we took the AWS from the EKS. If you have anything, if you have any issues with the EKS, if you have any issues with the EKS, we can connect with the AWS support team and resolve the issues. So who will manage this EKS? The Kubernetes will be managed by the providers. The Kubernetes will be managed by the providers. Amazon EKS, AKS, Amazon Azure Kubernetes Services. So Google GKE and Oracle OKE and IBM IKE, Alibaba, right? These all are the every cloud providers they launched their own Kubernetes service. If you took that service, right, they will manage the installation and everything. You just deployed your application on the Kubernetes cluster. Guys, now you understood? So provider managed use Kubernetes cluster and self-managed Kubernetes cluster. Guys, understood?
Yes.
Yeah, very good. Yeah. So Kubernetes cluster setup. How you can set up the Kubernetes cluster? There are multiple ways to set up the Kubernetes cluster: self-managed Kubernetes cluster and provider-managed Kubernetes cluster. Self-managed cluster means so we have to set up the cluster in Kubernetes to run our applications. Lot of commands to install the manually, right? To create a self managed cluster, we have two options. So we have a two options to create the self managed Kubernetes cluster. So one is Minikube. Minikube is nothing but a single node Kubernetes cluster. I already told you, right, guys? Minikube is nothing but a single node Kubernetes cluster, and KubeADM. KubeADM is nothing but a multi node Kubernetes cluster is nothing but a KubeADM. So within that single instance, we will create the queue, we will create the master node, we will create the that control plane services and the worker node, so services. So right. So in the development environment, QA environment, they are using the Minikube. So KubeADM, so multi-node Kubernetes cluster. What is that, guys? We need a multiple nodes to create the Kubernetes cluster. So one is master node, so other one is the worker node. If you want a one worker node, or if you want a multiple worker nodes, for example, your application. So for example, if you took the application like as a Where is it, guys? So microservice architecture. Kubernetes is a microservice architecture, guys. Where it is I created, right? Microservice architecture. Yeah. So microservice based application. So microservice based, for example, makemytrip.com. So makemytrip.com is the website. So this website having, so we can book the tickets from the flights, or we can book the tickets from the trains, or we can book the tickets from the buses, cabs, forex, holiday packages, homestays, hotels. So everything will be included in one application, right? So something like so you have wrote the code for the trains. You have a wrote for the codes and you deployed the new code in the trains module. So if something goes wrong on the train, so definitely it will be, so it will be, the application will be goes down, right? So that is nothing but a monolithic application. So what is the difference between a monolithic and microservices? So microservices, you already know, right, guys? The waterfall model and agile methodology. So in the waterfall methodology, every application will be deployed as a monolithic. Monolithic is nothing but a single deployment file. It will deploy all the modules, something like this, all the modules in the one deployment file, right? So if something goes wrong on the trains, the every application will be every application will be not working, right? So for that purpose, so if you segregate it in each module, so we can deploy it. If something goes wrong on the flights, that module will be affecting, the other modules will remain working, right? So that is nothing but a microservice based application. Microservice based application. Yeah, so real world applications. What are the real world applications? The real world applications are a monolithic architecture applications and microservices architecture applications. A monolithic application architecture means everything will be a part of one project. Monolithic applications are very difficult to maintain. It is very difficult to maintain. Microservices architecture, the whole functionality of the application divided into several sub projects. Right, guys? The whole functionality of the application divided into several sub-projects which are easily maintainable. The whole functionality of the application divided into several sub-projects which are easily maintainable. Set of APIs will be available and every API is one of application. So every API will contain a one container. For example, Make My Trip is implemented in microservice architecture. So what are those? So flights in one API, trains in one API, business buses in one API. If something goes wrong on the flights, only it will be effect on the flights only in the microservice architecture. So once we are talking to the Kubernetes is the microservice based architecture. Microservice based architecture, right? Yeah. So in the real time, so all are using the microservice based architectures. For example, so monolithic application is monolithic architecture application. So in one Docker container, our entire application will be deployed. But in the microservice based application, so for example, e-commerce website. So first we need to select the product API, right? So the products are in the one Docker container. So once product is selected, then if you click the cart API, so cart API is the another Docker container. So if you add it to the cart, right, then it will go to the payment API. So payment API is the one container, and once the payment API is done, so then the tracking. So where is your item? Where is your something like if you book the shoes, the tracking of the item, right? These all are the different APIs, and every API will be deployed under the one container. Every API will be deployed under the one container. Guys, understood? So now the difference between a monolithic architecture and a microservice architecture. Guys, understood? So in the real world, applications are getting developed using microservice architecture. In microservice architecture, several APIs will be available. Every API is a project and it should be run in a container. So running multiple containers manually of all the APIs is difficult job. To solve this problem, Docker Compose came into the picture. Okay. So who will handle that? That now the Kubernetes is the microservice based architecture. What is that, guys? Kubernetes is the microservice based architecture. Now you understood, right, guys?
Yes.
Yeah, very good. You guys understood, right? So the architecture. So the architecture is, so what is the architecture, guys? API server. So what is the use of API server? What is the scheduler? What is the controller? What is the HCD? What Kubernetes is doing? What kubroxy is doing? What Docker container? What is a pod? What is a container? So right. So we'll discuss. So master node manages the worker node in the cluster. It will assign tasks to the worker nodes for the execution. So we will execute this. Who will validate control managers, scheduler, HCD, API server. Master node manages the worker nodes in the cluster. It will assign tasks to the worker nodes for the execution. Worker node will run the tasks which are assigned by the master node. Okay. API server. So what is the API server? What is the use of API server? So in Kubernetes cluster, we have several services and objects. So what are the services? So something like these are the services: API server, and HCD service, and control manager, and scheduler. So the services are something like a pod, so replication controller, replica set, daemon set, deployment, volumes, so services. You already know the Docker volumes, right? You already know what is a service, what is a deployment, what is a daemon set, what is replication set. So what is the replication controller? What is pods? Okay. Yeah. So the Kubernetes cluster will be have a master node and worker node. What are the components in the master node? So API server, control manager, HCD, and scheduler. So pods, containers, Docker runtime, kubelet, kubeproxy, kubectl. Right. So what is a scheduler? So it will schedule the, first we need to know the API server. So what is API server? In Kubernetes cluster, we have a several services and objects. So pods, replication controller, replica set, daemon set, deployment, volumes, services. These all are the services and objects. All the above Kubernetes services implemented using the Go language. The Kubernetes implemented with the which language, guys? Go language. To use Kubernetes service, we need not to learn Go language. To use Kubernetes services, Kubernetes provided API server. Okay, when we execute a command in API server, we will interact with Kubernetes software. So when we execute the command in the API server, something like kubectl apply -f. So right, that is the command. So we'll interact with the Kubernetes cluster software and it will perform the required operation. So whatever we are mentioned in the manifest file, right, that will perform the option. So we will take care that one API server. API server will act as a communication channel between developer and DevOps engineer and Kubernetes components. API server will act as a communication channel between the developer, DevOps and DevOps engineers and Kubernetes components. Okay, so what is HCD? HCD is a key value pair data store in Kubernetes. What is that? It is a key value pair data store in Kubernetes. It acts as a database for Kubernetes. It acts as a database for Kubernetes. How many pods, how many nodes, how many containers are running. So where it will be available? The information will be available in the HCD. The information will be available in the HCD. How many pods, how many nodes, how many containers are running. So when we ask Kubernetes to run our application, then API server will receive that request and it will store it into the HCD. It will store it into the HCD. Guys, now you understood? Yeah. So what is that API server? The scheduler. So what is a scheduler? It will schedule pods for executions which are unscheduled based on the HCD. Which are based on the unscheduled. What is scheduler? The scheduler, it will schedule the pods for execution. For example, in our deployment file, we need to create a one pod. So who will create that pod? So that pod will be scheduled. First, we need to schedule that pod. It will schedule the pod for the execution which are unscheduled based on the HCD. So in the HCD, we will get the information. This pod is still in pending. So whatever the unscheduled pods, right? So that will be added in the HCD. Scheduler will schedule the pods on the nodes with the help of kubelet. Scheduler will schedule the pods. So who will schedule the pods? The scheduler will schedule the pods on the nodes with the help of kubelet. So with the help of kubelet, kubelet is the agent. So kubelet is the worker node agent. It will validate it will connect to the API server. It will connect to the master node and it will validate. So the kubelet will check what are the unscheduled pods are there. So then schedule will schedule the pods on the nodes with the help of kubelet. Kubelet is a worker node component. Kubelet is a worker node component and kubelet is a agent, worker node agent. Scheduler will talk to the kubelet. Scheduler will talk to the kubelet and to check the resources to our own application. So scheduler will talk to the kubelet. Who will talk to the kubelet? The scheduler will talk to the kubelet. Okay. So what is a kubelet? Kubelet will act as a node agent, right? So same like as a Nagios agent, right? So NRP is the Nagios agent. So that will communicate with the Nagios server and it will check the services and servers, right? The same like as a kubelet. Kubelet will act as a node agent. Kubelet will ensure that the containers are running healthy in the pod. Kubelet will ensure that containers are running healthy in the pod. Kubelet will interact with the runtime. So, right, kubelet will interact with the runtime runtime to create the container in the pod. So here note here. So we will use the Docker runtime to create our containers. Kubelet. Who will use the Docker runtime to create our containers? Kubelet will use the Docker runtime to connect the containers, right? So what is kubelet? What is a scheduler? What is a API server? What is a HCD? What is a HCD? Then what is the kube proxy? kube proxy act as a network proxy. What is that, guys? Kube proxy act as a network proxy. Kube proxy will maintain network rules on the pods. Kube proxy will maintain network rules on the pods. Who will maintain the network rules, guys? So the network rules will be maintained on the pods kube proxy. The network rules allow network communication to your pods from the inside or outside of the cluster. I want a network IP. I want a IP address of that server container. So who will do that? The kube proxy will maintain the networking on the Kubernetes cluster, inside and outside of the cluster. Okay. What is a control manager? So control manager runs controls in the background. It is responsible to run tasks in the Kubernetes cluster. It performs Kubernetes cluster level operations. We have a several controls in Kubernetes, several controllers. So what are the controllers? The controls are node controller, replication controller, endpoint controller, deployment controller. We have a several controller. Controller manager runs controllers. Controller manager runs controllers in the background. It is responsible to run the task in the Kubernetes cluster. So who is the responsible for the to run the task in the Kubernetes cluster? Controllers. So what are those controllers? The controllers are the node controller, replication controller, endpoint controller, deployment controller. These all are the controls. These will be working on the background. It is responsible to run the Kubernetes cluster. Right? What is this, guys? Yeah. So in order to increase the intelligence, I think it is a pod, right? So pod can run single container as well as a multiple containers. I will tell you guys. Okay. So Kubernetes self, I already told you, right? So this is the self-managed and the Kubernetes setup. Kubernetes can set up into multiple ways: self-managed and managed Kubernetes cluster. AWS EKS, Azure AKS, GCP GKE, IBM IKE, right? So Kubernetes cluster setup. So provider managed cluster means we will use Kubernetes cluster which is configured by the someone. EKS, Elastic Kubernetes Service, Azure AKS, Azure Kubernetes Service, and GKE, Google Kubernetes Engine, and IKE, IBM Kubernetes Engine. So these all are the provider managed Kubernetes cluster. Okay. So EKS by AWS. So this is just EKS. You can run the commands. If you can run the few commands, it will automatically create the Kubernetes cluster. I will show you guys. Yeah. So this is the EKS setup. So create a EKS management host in AWS. How to create the EKS management? Launch a new Ubuntu VM using AWS EC2 instance, T2 micro, connect to mission and install the kubectl using the below commands. Okay. So with this is the remote mission, guys. This is the remote mission for to connect the Kubernetes cluster. Okay. Install AWS CLI in the latest version in the below commands. So first you can install the kubectl, then the AWS CLI and install the EKS-CTL. So this is in the remote mission. Okay. So step to create a IAM role, attach the EKS management host. We can create the attach. So create a EKS cluster using the EKS-CTL command. Just this is the command you run. So in the North Virginia region, Mumbai region, you just run this command. It automatically create the cluster, guys. Okay. So this is nothing but a Kubernetes cluster creation. So Kubernetes cluster setup. Create one security group with protocol of all traffic port range 0 to 655. Create 3 Ubuntu servers and above created security group. So this is nothing but a self-managed Kubernetes cluster. So Kubernetes Minikube meaning. So Minikube is a one node Kubernetes cluster where master process and worker process both are run on one node. According to the official document of a Minikube, Minikube is a local Kubernetes focusing on making it easy to learn and develop of Kubernetes. A prerequisite to use Minikube is a Docker container or a virtual machine environment. Minikube provides you to a way to easily deploy application on Kubernetes for learning and developing purpose, even if you don't have enough resources like memory and CPU. Okay, so now you understood the Minikube, right, guys? So what is Minikube? So Minikube quickly set up a local Kubernetes cluster on the Mac OS, Linux, and Windows. We providely focus on helping the application developers and new Kubernetes users. So supports a latest Kubernetes release, cross-platform, deploy a VM and container or a bare metal, multiple container runs on one direct API endpoint of the blazing fast, advanced features such as load balancer, file system mounts, future gates, and network policy add-on is easy. Okay. So Kubernetes cluster architecture. So what is the Kubernetes cluster architecture? This is the AWS cloud. In the AWS cloud, you need to create the VPC. In the VPC, you can create the, so this is the Kubernetes master node. In the Kubernetes master node, kube controller manager, kube scheduler, kube API server, HCD proxy, and kubelet. Right. So this is the worker nodes. So in this worker nodes also, we will create it. Okay. So self-managed, we need we take three Ubuntu's. One is master node, two is worker node. Install Docker Kubernetes in both master and worker nodes. Install kubeadm, kubectl in master node. Okay, how to install the kubeadm and kubectl? Right, running Kubernetes. Master node setup, this is worker node setup. So is it recommended to run the command in the master node? We can access the master node from the remote mission using the kubectl command. Okay, so this is not a right way to run the directly commands on the master node. So we can create another remote mission and you copy the config file, kubeconfig file, and run the commands in the remote file. Okay. So for the EKS EC2 instance, it will install the kubectl and EKS-CTL. So right, this is the Amazon EKS. So in this is the control plane. In the control plane, so we have a three instances. Okay, Kubernetes architecture. Now you understood, right? So launch a new EC2 instance VM for running the Kubernetes cluster. So just launch the EC2 instance, install kubectl. So install, right? Take the kube config from the master and it keep it here. So we can keep it here. So Kubernetes core concepts are container, pod, namespace, service, deployment. Kubernetes resources, objects, and workloads. So what are the core concepts, guys? The core concept of the Kubernetes is container. What is a container? And what is a pod? What is a namespace? What is a service? And what is a deployment? These all are the core concepts. These all are the core concept. What is a container? What is a pod? What is a namespace? What is a service? What is a deployment? So Kubernetes, a pod, container, namespace, service, deployment, replication controller, replica set, daemon sets, persistent volumes, so stateful sets, so role, secret config. So these all are the resources, objects, and workloads. Okay, so we are using Docker to create a container for our application. Docker will be used as a runtime engine to Kubernetes cluster. Kubernetes is used to manage our Docker containers. Kubernetes will manage our containers, but not directly. It will use pod to manage the container. Pod is a, so how to manage the containers in the Kubernetes? So pod will manage the containers in the Kubernetes. First, what is a pod? A pod is a smallest building block which we can deploy in Kubernetes cluster. What is that? A pod is a smallest building block. It's a smallest building block which we can deploy in Kubernetes cluster. A containers will be wrapped under one unit called as a pod. So logical grouping. So note in Docker, container is the smallest part that we can deploy, where as in Kubernetes pod is the smallest part we can deploy. So to get clarify on pods, we need to understand the namespace first in the Kubernetes cluster. What is namespace? What is a namespace creation? Pod using the custom namespace, creating a namespace. So we'll discuss on tomorrow, guys. Guys, understood? Guys,
Yeah, yeah, okay.
Yeah. Thank you guys. Thank you so much. We'll continue from tomorrow.